This is chapter 12 on solutions, and in this section, 12.4, we're going to talk about concentrations of different solutions. We're going to see it in other sections as well. There's different ways to rate how concentrated a solution is, but just generically, a concentration is how much or a relative amount of solute within a certain amount of solution. So if you put 1 teaspoon of salt in a glass of water, you have a certain concentration. If you put twice as much or 2 teaspoons, you're going to have twice as much concentration, etc. So there's various ways of doing it. We can look at the weight. So for instance, if you have an amount of solute and you're putting it, let's say solid salt, you're putting it in water, you could weigh the water and then do a concentration based upon how much solute within how much solution. Or if you had a liquid solute, say you're putting alcohol in water, you could measure the amount of alcohol that you put in, measure the amount of water that you put it in, and then you'd know a concentration that way too. So let's get started. A percent concentration is based upon 100 of something. If something is percentage, it's out of 100. So normally this is either an amount of weight or an amount of volume out of 100 of that same amount. So either it's out of 100 grams if it's a weight, or 100 milliliters, say, if it's a volume. So the first one we're going to look at is mass percent. It's M over M as its notation there, mass over mass. So you're looking for the mass of the solute. The solute's always on the top. The solution is on the bottom. And I would make a note about that, because that could be confusing to know what do I put on the bottom. Is it the solvent? Not in this case. It's going to be the solution itself. And the solution has two parts. The solution is the solute plus the solvent. The solution is the whole thing. So if you're going to have a mass percentage, mass-wise, you're going to have grams of solute over 100 grams of solution. And then if you want to express that in percentage, you're going to have to multiply that by 100. So here's an example. If I have some potassium chloride, have 8 grams of it, and I put it in a glass and then add water up to 50 grams. Okay, so I would know that if 8 of those 50 are made up of potassium chloride, the other 42 has to be the water. But I really want not just the water, I want to know what the weight of the water plus the solute is. So the whole thing, because that's what I'm going to divide by. The bottom number is always going to be the solution when you're doing percentages, percent composition. Okay, so if I know now that I've got 50 grams of solution, I simply take 8 grams of the solute, the potassium chloride, and divide by 50. I express that in percentages, and I get 16%. Here's a picture of that. You simply tear out or zero out the glass, the beaker, put in 8 grams of the salt that you're talking about, and then you want to know what the total weight of the solution is. So you simply add up water until you get to a solution the amount of solution that you're talking about. Then you divide those two numbers. So here's the schematic of how to think through this. You're going to first of all determine, you need to know what your solute and what your solution is and how much of them you have. Then you write the expression and substitute the numbers in for that expression. Okay, so here's some examples. First, before I give you an example, I need to give you the second one. Remember I said the one would be mass over mass, so grams over grams, grams of solute over grams of solution. That's mass percent. This is volume. If you have a liquid solute, so let's say I'm putting acid and mixing it with water, or I'm putting alcohol and mixing it with water, I'm diluting it. Okay, so you have something concentrated. You have concentrated orange juice, and you add water to it to dilute that concentration back to what you would want to when you have orange juice. You would find out a volume of the solute divided by the volume of the whole solution. Okay, so this is, instead of M over M, we now have V over V, volume over volume. So in the lab, we don't usually deal with large amounts. So milliliters are just very small amounts that you do on the laptop. So you have milliliters of solute divided by milliliters of solution. And again, it's not the solvent you're dividing by, it's the whole solution that has the solute and the solvent together. And then express it in percentages by multiplying by 100%. This is how you do it. You use a volumetric flask. And a volumetric flask is a kind of an interesting piece of glassware that has a line along the neck. And if you put water or any liquid up to that line, you have exactly that amount, and it's written on the side of the flask. So this example, there's 250 ml flask, but you have all kinds of flasks, liter flasks or 10 ml flasks, or depending on what you have. I think we have a number of them in the lab. So here you're going to add, this example looks like it's ethanol, so ethyl alcohol. You're putting in 5 mils of ethyl alcohol in the bottom of the flask, and then filling it up with water up to a certain line so that you have exactly that much, and then that's how much that goes on the bottom. That's the full solution that you'll have on the bottom. So this is the review of the two that we've looked at today. We're looking at mass over mass, so M over M, where you're going to have mass or grams of a solute over grams of the total solution, and then volume over volume, where you're going to have a volume of a solute, those are the liquid solute, over the entire solution. Okay. So if you're using concentration to calculate a number, most of the time you're going to have one thing missing. You're going to have one piece of information missing, everything else found, and you put it in its configuration so that you know what it is that you're blubbering. For instance, if you have mass over mass, you would have grams of solute over grams of solution equals a decimal. And then that decimal can be expressed as a fraction. You have 3 pieces of information. If I give you any of those 2, you should be able to manipulate it to find the third. That's what we're going to do. So here's an example of that. How many grams of sodium chloride are needed to prepare 225 grams of a 10% mass over mass NaCl solution? Okay, you can do this several different ways, and I know it looks scary, but really it's not that hard, because what does 10% mean, mass over mass? It means you're going to have grams of a solute over total grams of solution equals 0.1. Because if you express 0.1 as a percentage, you'll get 10%. If you want to go backwards from percent to decimal, you have to divide by 100, which is moving the decimal 2 to the left, and you'll end up with 0.1. So I know 0.1, it's given, and I know 225. The other thing would be the x. So you're simply going to put it together as x, which is your solute, over 225, which is your solution, equals 0.1. So you're going to take 0.1, multiply by 225, and you get your answer. Now, the book did it a little bit different, and I like this too. And they're using kind of a ratio. They say if it's 10% by mass, then for every 100 grams of solution, you're going to have 10 grams of solute. That's what 10% means. So 10% means 10% of the total mass is the solute and 90% is the solvent. In that case, you'd have 10 grams of sodium chloride over 100 grams of total solution, and you can use that as a conversion factor. So it's 10 grams of sodium chloride for every 100 grams of solution. 225 grams of solution is what we have, and we're trying to find out what the new amount is. Divide by 100, multiply by 10, and you're going to get 22.5 grams of sodium chloride. I know this is a little bit confusing. You can go over this again, of course, but otherwise I'll see you in class.